This is old stuff. Newspaper posted this question on its web. These are just old ones we've done before. These old homework questions. How often do you seek medical information online? Of 1,072 internet users who chose to respond, 38% of them responded with frequently. What term is used to describe this type of survey, which the people surveyed consists of those who decided to respond? What is wrong with this type of sampling method? Okay, so what term is used to describe? So remember way back, Chapter 1, we were talking about like methods of gathering information.
Voluntary?
Yeah, we talked about good ways and bad ways. You know, it's been a long time, and ever since then we've been doing stuff with it. See how this course worked? The beginning, the first exam was all about what is a wise way to gather information. And then everything since then is, okay, now that you got the information, what do you do with it? How do you draw a conclusion? So, what did we learn back in the what's a wise way and what's a foolish way to gather information? So what's wrong with this way? What's wrong with putting a question on a website that says, how often do you seek medical information online? And 38% responded frequently. So what would be wrong with somebody saying, hey, they posted this question.
We don't have to respond to middle one.
Is it not? Yeah, you're totally right. Is it not writing up there?
What?
Whatever, there's my writing. Okay, yeah. And so, okay, so, yeah, exactly right. What's wrong with this? Voluntary response, right? Everybody hear what Ma and Val were saying? They're right on. Remember that? Why is that bad? Why is voluntary response bad? Why are these, you should not believe these results. And somebody said, look, we did a scientific study and, you know, put it on the internet and 38%, so it must be 38% of all the people in the world frequently seek help online.
It doesn't reflect the opinion of the general population.
Yeah, it doesn't reflect the opinion. You could be a spokesman, Val, for that. It's perfect, beautifully said. Yeah, it doesn't reflect the general population's opinion, right? It's just the people. Whenever you do a voluntary response sample, you're only getting the eager beavers. Remember us talking all about that, right? If you know, if you just do a survey where a lot of people don't respond, then you're not getting their opinion. When they put something on the radio or on TV or on the internet that says, what's your opinion on this issue? Click in or call in or let us know. The regular people don't answer. You're not getting the general truth. What's wrong? Yeah, responses may not affect the opinions of the general. Oh, you were just reading that.
Would you not put the self-selected sample?
Good question. It is self-selected.
So
The respondents are, oh yeah, there's more than one, huh?
Yeah.
Thank you, Haley. You're totally right. It is self-selected. And it is, yeah, there's more than one. Respondents are voluntary. I didn't read the thing. Select all that apply. You're right.
Many people may choose not to.
Not the other two there. And what's the other one? Many people may choose not to respond. Yeah, thank you. You're right. And respondents may not reflect general population. There we go. And those are the problems with it, right? A lot of people choose not to respond, yet they have an opinion. So to draw a conclusion on a study that says, hey, I guess 30% of all the population feels this way, that's just not true. It's a bogus way of gathering information, yet it's done all the time. It's not really getting at the truth. That's what statistics has been all about, hasn't it? Can we get to the truth of whether a new procedure works or what the population really thinks? GPA, calculation. So there's one of these on the final. I thought you should be able to calculate your GPA coming out of statistics. Remember how that works?
Kind of.
Kind of, sort of?
Divide by the total number of users.
Yeah, I'll write something up for you. This is all going to be on YouTube after class. Yeah, so basically, here's how you do GPA. GPA, so we're doing question number 2 here. So GPA, they're basically telling us, what are they telling us? What is the GPA of a student who got an A in a 3-unit class, a B in each of two units? So they got an A, a 3-unit A, two 2-unit Bs, is that right? A B in each of two credit courses, and a C in a 3-credit course. They got a C in a 3-unit course, and a D in a 2-unit. Yeah, D in a 2-unit. You got a 2-unit, they got a D. So that's what the student did. How do we calculate their GPA? Well, remember, A is worth 4.0, B is 3.0. You know this. C is 2.0, D is 1.0. So what do? You better remember.
You multiply the 3 by the 4
Exactly. You just take the units. You just take units times the grade points. So 3 units times an A, which is 4.0. That's 12. 2 units times a B, which is 3.0. That's 6. Again, 2 times 3.0, which is 6. And this is 3 times 2.0, which is 6. And this is 2 times a D, which is 1.0. Add them up. So you just multiply units by grade, units by grade, units by grade, units by grade. Add them all up. Is that 32? 32, yeah. 32. And then what do you think you divide? We need an average, right? It's a grade point average. So averages we always have to divide by the total number, right? That's how you figure an average. You add them all up and divide by how many? So what are we going to divide by? What's the how many? Units. That's how many units. So you add all these up and you divide by the number of units. So what's the number of units? Add these up. 3, 4, 5, 6, 7, 10, 12. Person took 12 units. So 32 divided by 12, and just use your calculator. It's 2 point, I don't know. What is it? Yeah. So we'll just round to 2 places. 2.67. That's their GPA. See how that worked? So you just multiply. So you can put that, you get a full sheet of notes. So you can write that in a small corner. I would encourage you to start making that even right now. Just have a separate piece of paper, and you can always clean it up later. Just start. We're going through the practice final right now. This is how you should make your final study sheet. Is just as you go through the practice final, throw on there anything you need. So you just multiply units by grade, add them all up, and divide by total units. That's the grade point average. 2.67. Good. Questions on that? So it's okay. 3. Look at you don't write all those down. Got a whole bunch of numbers, and it says find the percentile of 11.7. Now to do that, we have to remember what in the world is percentile. Does anybody remember?
Anything underneath that number?
Yeah. What is it? It's the percent below that number. Yeah, percentile is percent below. So good thing to just put right on your sheet of notes. Even right now, just put that on your final study sheet. Percent below that number. So when they say find the percentile of 11.7, they mean grab the 11.7, which is right there in the data. Notice they're put in order. Right, the numbers are in order from low to high. And find out what percent, what chunk, what part of all the numbers of that whole list, what part of that whole group of numbers is below the 11.7. Says up, doesn't it say the total amount of numbers somewhere?
41, 50 altogether.
How do you know? Does it say you're just doing 5 times 10? Yeah, good job. Yeah, if you just count it, it's just 5. I thought they would say it, but I guess they don't. It's 5 down, 10 across, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 10. 5 by 10. So there's 50 numbers up there. Right? You with me? So there's 50 numbers total. So, and how many are below? Like, how many are in this chunk? Let me circle it.
41.
Yeah, because there's only, yeah. It must be 41 below. Yeah, because there's 40. Yeah, that makes sense, huh? 40 in these first row and then one more. 41. There must be 41 out of 50 numbers. And then just divide that in your calculator. You'll get 0.82, which means 82%. So 82 percentile. 82 is the percent of all the numbers that are below that number.
So it's everything below that one.
It's percent below that number.
And then just divide by the total. Like
Right.
how many?
Yeah, that's the portion. You with me on that? So there's 50 numbers up there. 41 of those 50 numbers are below 11.7.
So
Aren't they?
we don't include the 11.7?
Right, good question. We do not. Exactly right. We do not include it itself, just those below it. Good clarification, yes. We good on that? So it's just the chunk below. It's the portion. 41 out of all 50 numbers are below 11.7. Just divide that in your calculator. That's the 82 percentile. So that's what they mean. You know, when I made the... So now the next question is a little more formulistic, number 4. Let's, 4, now they're saying find the P40. So what they're saying is, among all those numbers, that's probably well, it's a different data set, I guess. Anyway, among all those numbers up there which are in order, find the 40th percentile. Find the one that has 40% below him. That's what they're saying. This making sense so far? Let me ask you this. It's always good just to have a common sense of things. Is the number going to be more than halfway through the list or less than halfway through the list? A little bit less, right? 40% is under 50%. So just right off the bat, multiple choice, you could probably, you know it's going to be, like, where's half? This is about halfway, isn't it?
Right.
So it's going to be, I don't know, somewhere over here. It's probably going to be one of those 1.8s or 1.9 or, around there, right? It's probably about, or maybe a 1.4, I don't know. But that's about 40% of the way. Now, I'm going to give you the technical steps and everything. But I just want you to have a feel as well, because it's easy to hit a wrong button in your calculator. It's good to have a feel. So it's whatever number's about 40% of the way through the data set. 40% below, right? All right, so how do we actually find it? Okay, there's actually some steps. What you do is you take that number, 0.40. Here, let me just write them out for you first. So step 1, multiply the decimal of P times n. What is always n in all the statistics? Total number of numbers, yeah. And we got 50 here again, don't we?
So it would be 0.40 times 50.
0.40 times 50, exactly. 0.40 times 50. So 0.40 times 50. What is that? Is that 20?
Yes.
20, yeah. So 20. Okay, now there's two things you do with that number depending on whether it comes out a whole number or a fraction. I don't know if you remember any of this.
I forgot all of that.
If you get a whole number, which we got a 20 straight, no decimal, right? Whole number, then what you do in that case, when you get a whole number, is you grab that number and the next number in the data and average them. Yeah, add them and divide by 2. And, take the average of them. Whereas the other thing that can happen is if you get a whole number. If you get a decimal, if I got like 20.1 or something, yeah, let me just write. What if I'd gotten 20.1? You round up and get the 21st number in the data. So we're always going up to the data set, grabbing a number. Either, if it's a whole number, we grab that number. So what's the 20th number in this data set?
1.8.
This one right here. That's got to be the 20th number, right? Because it's 10 per row, right? So 10, 20. So that's the 20th number. So you multiply the P times the N. You get that. If it's a whole number, grab the 20th and the next one.
They're both the same.
They're both the same, yeah. So they're both 18. They're both the same. So you grab them both. I'll bring it over here, and then you take 18 plus 18 divided by 2. Obviously, that's just going to be 18. The average of 18 and 18 is 18. So that's our answer. Answer to this question is 18. But if it had been a decimal, say we'd gotten 20.1, then you round up. Even 0.1 goes up and grab the 21st number. Of course, that's still an 18, but sometimes that would be different.
The answer is just 18?
It's
1.8.
Oh, thank you. My eyes. I'm not seeing those decimals. I'm sorry, guys. I'm totally confusing you by not seeing those decimals. 1.8. That's supposed to be 1.8. Sorry. Yeah, that was not helpful. All right, sorry. Yeah. The 20th number, can you tell I'm old? The 20th number is 1.8. 1.8. So, yeah, thanks. Sorry. Yeah, it's a 1.8. Does that make sense then? So you want to have on your sheet, there's two options for that. Again, you just take the P times the N. What you get's a whole number. Then grab that spot and the next spot in the data and average them. 20th number, 21st number, 1.8, average them, add them, divide by 2. If it's decimal, 20.1, round up, grab the 21st number. Just that number. That's all. No two numbers averaged.
If you get a whole, you add the one you get in the next one.
Yes.
And then divide that by.
By 2, because you're averaging them, right? The average things you add and divide by 2. Yeah, like if you average your test scores, right? Add them and divide by 2. Good on that. So have that on your
And
sheet.
if you get a, I'm sorry.
Yeah, if you get a decimal, that's okay, Haley. Yeah, if you get a decimal, like say like 20.1,
Yeah.
you round up to even 20.1 goes up to 21.
Okay.
Like yeah, so it's not just rounding off. It's not just 0.5 that goes up. Everything goes up, and then grab that spot. Grab the 21st number.
And then just keep that.
Yeah, so the answer is not 21, it's the 21st number, right? Which would still be 1.8 in this case. All right. So they give us a whole bunch of data, and they want the 5-number summary and the box plot. This is all going to be calculator. Remember what you do? You just put all that stuff in L1. Just put all these numbers in L1, and then you hit stat and something else. Oh, calc. Go over to calc and do one variable and just hit enter a bunch. You might need to put in L1. I don't know if calculators are different. So when I did it, so now what are the 5 numbers? Let me show you. The first one is the lowest number, and the last one is the highest number. So I don't know if it shows you those. Oh, yeah, it does. It says minimum. Yeah, so it says minimum. It does. Okay, great. It says min, so the minimum number comes first, which it's telling me 120. And then it's telling me this is Q1, which is 126. This is the median, which is 130.5. This is Q3, the end of the third quarter. It's like a basketball game or something. It's the end of the third quarter of numbers, 135. And the max, the highest number in the data set, 150. There's the 5 numbers. It's called the 5-number summary. It's a way of summarizing all those numbers.
So min.
So yeah, so it's the lowest. So if you think about it, it's like a football game or a basketball game. Lowest number into the first quarter, second quarter, halfway. Third quarter, highest. That's what it's doing. So it's like, like a basketball game starts, and then there's the end of the first quarter, then there's halftime, then there's the end of the third quarter, then there's the end of the game, huh? That's what it's basically doing. It's breaking the data into 4 even chunks, like 4 quarters in a football or basketball game. And then you just find which of those graphs down below looks right. So like the way the box is supposed to go, the box is supposed to go from the Q1 to the Q3. Let me erase some of this. The box is supposed to go from Q1 to Q3. And then a line is supposed to go down to the minimum and up to the maximum. And there's supposed to be a line at the middle. Haley.
In the bar.
Yeah, this is the homework. This is the practice final.
Yeah.
Yeah, this is what's due. Yeah, this is due on Monday.
Okay.
Yeah, this actual practice final. This is what we're doing on Monday. So that makes sense. Then the Q1 is at 126. So this is wrong. This is hitting it like 122. This left edge, same thing, 122. This left edge is like 122. It's not even up to 125. This left edge is looking good. So the answer is A. We good? All right, so we're moved in. Yeah, the first 5 questions were from exam 1. We're done. This is now exam 2 for the next 7. It may be 7 or 8. I threw in an extra one somewhere for extra 2. Anyway, for about the next 7 or 8 questions, it's going to be exam 2. So now it's exam 2. Exam 2 is all about probability. So, chances of things. That might be the trickiest. That was for me. As I look back over it, it was hardest for me to remember exam 2. Binomial theorem, remember some of those weird things? Good that we review those in the next hour. Remember the ones where we had to hit the binom PDF and that stuff? We need to review that. So, all right, so let's start here with number 6. So basically it's giving you some drug test information, and it's asking, what's the probability of a false positive? So no formulas are needed for this one. It's just about thinking about what it's saying there. So false positive. So positive test results but false.
2.
Right there. That too, yeah. Because they're not drug users, yet they tested positive. It's a false positive. So what's the probability? Now remember, probability is always whatever number out of the total, isn't it? So it's 2 out of however many total. 75, yeah. So if you add them all up, it's 75. So 2 out of 75, divide that on your calculator. They want it rounded to 3 places, they say.
027.
6, 7.
Yeah, so I'm getting 2666666. So 3 places, that'd be 027. 027. 0.027. That's the probability. So notice it's about a 2.7% chance of getting a false positive. That's what we're determining. So if that's how that drug test works, 2.7% of the time they're going to get a false positive. Is what that means. We okay with that? See how we read that chart? So probability, remember as we're moving into the probability section now, remember the bottom of probability is always the total. Now, who would suffer from a false positive and why?
Or employee.
Yeah, the person tested would suffer, right? Because they're saying they're a drug user and they're not. Because he or she is suspected of using drugs when in reality they don't, right? It's a false positive on that. Yeah, Michaela.
When we put the answer in, it's 11.8%, right? Or is it 0.0?
They don't say they want to, they just want a decimal. So yeah, just leave it like that. So, was that your question? Am I answering your question? Yeah, don't make it a percent. They would have put a percent there if they wanted us to. Good? On we go. Okay, so use the following results. Test marijuana use, provided certain drugs, blah, blah, blah. 148 subjects, positive test result, 27 false positive, 24 negative, 3 false negative, blah, 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 blah. Yeah, this is actually really good. Make a table. Can you take those words and make a table? I'm going to help you make the table. So I'll make it like this other one. Positive, negative, user, not user. Okay. So positive or negative test result, user or not a user. And so what does it say? It says 148 subjects with positive. So that's the total here, isn't it? That's 140. That's the total positive results. 27 of them were false. So that's 27 of them were really not users. Let me pause there for a second. See what I'm doing? It says 148, they got a positive result, so I put that down as the total for positive. 27 were false, meaning they were really not a user. It's a false positive.
So 121.
Yeah, so then subtract. Good job.
148 would be on.
That'll be 121. What's that?
That's right.
Yeah, the 148 is the total that got positive, right? 148 subjects with a positive test result. And then next, can you do the next one? It says 154 negative, that's a total, negative results. Yeah. And three are false. Now, where does the 3 false negatives? Yeah, good job. It's their users. They really are users, even though it came out negative. And so then subtract 151. So there's our table. Now we can try to answer their question. What is their question? I don't know. Where is it? If one of the test subjects is random, so find the probability that the subject tested negative or did not use. Tested negative. So that's tricky in itself. So, okay. Probability that they test negative or they were not a user. Test negative or not a user.
Would you just add the 27 and 151 together?
Yeah.
Tested negative or not a user.
And divide by the
Divide by 302.
Is that what the total is, 302?
302, so you go 27 plus 151 is 181
So that'd be
over 302.
almost. There's something we're leaving out. So y'all are saying just those two?
Well, 3.
Over 302, is that what it is, the total 302? Yeah, it is 302. That's not quite right. That's really close.
Don't you have to add the 3 too?
Yes. This must be included. Right? So it's not only this and this, but the 3. Why? Because it said, I want everybody in here who either tested negative or is not a user. These 3 people tested negative, didn't they?
It's literal, huh? Because I was thinking,
Yeah.
but he's a user,
That makes sense? So everybody that either tested negative, which are both these two, the whole 154 tested negative, and then the other 27 are not. There's a lot of ways you can do it, but then you got to use those 3 groups. All of those groups are included in those words, aren't they? Not making sense?
Mm-hmm.
It's saying tested negative, so that's both the 3 and the 151, the whole 154, tested negative, or not a user. That would also throw in the 27, who, although they tested positive, they're not users.
And then you divide by the total.
And divide by, yeah, it's always total in the bottom of a probability, huh? Exactly. It's always so plus the 3 there, and that's always the total. And then, so whatever that is, 154, 74, is it 181 over 302? Is that what it is? Okay. 302. I'm getting 599. So how many places do they want? 3.599. 0.599. Yeah, so that's not easy. Those or questions are not easy. You gotta be careful about including all the groups there. Good? On that? All right, good. Okay, so the state's pick 3 lottery game. You pay $1.46, select a sequence of 3 digits, such as 911. If you select same sequence of 3 digits that are drawn, you win and collect $477.38. Complete parts A through E. How many different selections are possible?
1,000,999.
Yeah. How many? So what they're saying is you pick 3 digits, like 525 or 471 or 608 or whatever. You pick some 3-digit number, and one of those is going to be a winner. So what's the chance that you pick a winner? How many different? Careful now. All these you got to be really, really precise.
1,000.
Yeah, there's 1,000.
1 out of 1,000.
Because you think, well, isn't there 001 through 999? Isn't that just 999? Yeah, but there's also 000. That is an option. So that's 1,000 different 3-digit combos. Do you see how I'm coming up with that? Right? Because 1 through 999, that must be 999, and then you got to throw in that 000. So there's 1,000 possible, aren't there? 1,000 possible 3-digit combos. So 1,000. So what is the probability of winning then?
0.999.
It's going to be whatever. It's going to be 1 in 1,000, isn't it? Right? Because you're just picking one number, one 3-digit number, and you're hoping it's the one that the machine picked, right? The winning number. So that's going to be 0.001. They want a decimal. We good so far? How are we doing? Y'all getting kind of quiet. Want me to talk more about this? Is making sense?
Yeah.
You don't seem very happy about this. It's making sense so far. So there's 1,000 different numbers, right? 3-digit numbers. And the computer thing is just going to pick one of them. So the chance we're going to get that one is 1 out of 1,000. We just have one 3-digit number out of the 1,000 different possible 3-digit numbers. Our chance is 1 in 1,000, 0.001. Now, if you win, what is your net profit? Now, careful, when they say net profit, they mean net profit, and that means take out anything you spent, right?
477 minus.
Yeah, exactly. You got it. So whatever that is, yeah. So you got to take the
475.92.
is that what it is, minus the $1.49, $475.92. Thank you. So that's what you'd actually make, right? Because you had to spend the $1.49 on the ticket. So net profit means just that, what you actually profit. $475.92. And now find the expected value. It's all building up to expected value. What in the world is expected value? I debated about whether keeping expected, there's a lot of stuff I didn't put in here. There'll be none of those in formula ones. Remember those? Where we tried to find in the number, we had those crazy formulas I gave you? There's none of that. So there's a lot of things I cut out that I think, it's not important.
Yay.
But expected value, I tried to just put the main things. Expected value it's important because that's how insurance companies, gambling industry, all probabilistic things, that's how they figure out how to set their prices, how to set their gambling things. It's all, expected value is an average calculation in a probability world. It's what insurance companies, how do insurance companies know they're going to make money? Well, they have people that figure out the chances of different kinds of accidents and what they will cost. And then they calculate the average amount of money they're going to have to pay out per policy, and then they charge just a little more than that. So they make sure, on average, they make profit per policy. Gambling, it's the same way. They know exactly the average, and they just make sure that they're making a little more than they're losing. So anyway, so it's an important calculation. Lots of society uses it. I don't think so much you're ever going to probably directly use it as much as read it and understand it will be valuable. So anyway, how do we do it? We do it on our calculator. It's going to be on our calculator. And okay, so yes, I just sent you all these old notes. This is the exam 2 notes. And this is for gambling or insurance. So yeah, Val's right. You put in L1 and L2. Here's the dollars you win minus the cost to play. So we're going to put, in our case, L1, L2. So the dollars you win minus the cost you play, we already did that. That's net. That's here. That's what we did exactly right there, right? Dollars you win minus the cost, We did that. $475.92. So that's going to go right here. $475.92. That's the net. And then negative the cost to play. Negative, what's the cost to play? $1.46.
Negative.
Right, negative. Because what those numbers are? Those are what you're going to win or lose, right? If you win this game, you're going to win $475.92 net effect to your bank account. Because that's the winnings minus the cost of the ticket. If you lose, you're going to lose the cost of the ticket. That's why it's negative. So that's what's going to happen when you buy a ticket for this lottery. You're either going to win net effect to your bank. Your bank account's either going to go up $475.92 or go down $1.46. So that's just to help you remember. That's gain or loss. And then over on the right, you put in the L2, you put the probability. What's the chance you're going to win? 0.001. So that's the chance of winning. What's the chance you're going to lose? Yeah, 999, right? Because it's 1 minus. Everybody good with how we got that? 1 minus 0.001. Chance you're going to lose is 999. Okay. Put that into L1, L2. Hit stat, calc. Enter L1, L2, or L1 and L2 on separate lines. I don't know what that means. It says it's different for different calculators. And the mean will be expected value. Yeah, I should have said 1 var. You guys are right. It's 1 var. Stat, calc, 1 var, 1 variable. I should have put that in. And then depending on if you have the new or the old, I have the old. I do L1, L2. Some of the newer ones do like an L1 and L2 on separate lines. Is that what they do? And the X bar I got is minus 0.98. Did y'all get that? Minus 0.98.
Wait, how do you get the
Let me clarify. This should be,
average?
yeah, so it says, yeah, we just want the X bar. So it says list
Are you kidding me? It's how you know the expected value.
and frequency list. And so you got to put L1 and L2 for the frequency list. And there's the answer you should get. All right, good question. What does this number mean?
Expected value.
Yeah, and what is expected value? Like if you were to explain to somebody who never took stats, what is that?
What's your expected, so if you have it, like when you play?
Yeah, on average, what you expect to happen. You're going to basically lose, it's negative, so you're going to lose $1 every time you play this game, on average. Now, in reality, you can't ever lose exactly $1. You're either going to lose more or less, but that's what it's like. That's how the people that design the insurance companies, casinos, that's what they think. They're calculating that every time somebody plays, they're going to lose $1. They're going to give us $1. That's the average transaction that will happen per roll of the die or purchase of the insurance policy or whatever. That's how they calculate. That's the average result. All right. So this is for me, it was negative 0.98. And what's the final question? You bet $1.46. There's that. Oh, and the expected value is 0.98. Which is better? Well, that's the same thing. Yeah, that's exactly the same. That's kind of a dumb question.
You're not gonna put that in there.
No, I'm not going to put that dumb question. All right, let's move on. We'll see as we go, but I think no. I think I'm remembering right. Assume that when the adults was number 9. Remember number 9? Assume that when adults with smartphones were randomly selected, 41% of them use them in meetings or classes. If 5 adults smartphone users are randomly selected, find the probability that at least 3 of them use their smartphones in meetings or classes. What in the world is this? Been a while. So what they're saying is 41% use their phone in meetings or classes. Okay? So what's the probability that at least 3, if 5 adults are randomly selected, so out of 5, what's the probability that at least 3, so if you just grab 5 adults at random, what's the chance you're going to have 3 or more, at least 3, use it? So here's the notes. It says you have a percentage given, no mean, no standard. That's us. We got a percentage. There's no means or standards anywhere. So you know it's a binom. Right? So that's a good thing to help put on your sheet. You know, if you got a percent with no mean and no standard, that's us. We got a percent, no mean, no standard deviation given anywhere. So it's a binom. Now, are they saying exactly? No, they're saying at least. Right? That's ours, at least. So we're matching it up there, at least. It means like that or more. So the opposite, so you got to think about the opposite.
Yeah, 1 minus the answer.
Yeah. And then 1 minus the answer at the end. Yeah. Remember all that? Remember that was tricky. Remember I struggled to explain it.
Oh, yeah.
And some of you may have struggled to understand it. And it was kind of a difficult topic. Yeah. So let's think about what's happening here. So it's saying at least 3. So what does at least 3 mean? If I say I got at least 3 coins in my pocket, that's always my analogy.
2 and below.
If I say I've got at least 3, I've got 3 or 4 or 5, etc. So the opposite would be 2 or below. Yeah. So the opposite.
Why do you do the opposite again?
Yeah, good question. It's because that's the only way the binom thing works on your calculator. Right here. When you use it, you have to put in that or below. That's the only way it works. They just designed it that way. So yeah, we've got to have below. So we go binom CDF, notice, CDF, number of trials. What's the number of trials?
5.
It's 5. Yeah, it's out of 5 adults. So out of 5 adults, what's the probability that at least 3, if you grab 5 adults at random, what's the chance that at least 3 will be using their cell phone in meetings and classes? So number of trials is 5. The probability of 3 or less. In our case, see how it's always or less? That's just the way the function was built. So when they programmed this into the TI, they had to decide whether to make it work for numbers are bigger or numbers are less.
How do you get the binom?
So
Ours.
they went less. So we're going to put a 2 there. Get that answer. But then that's the opposite, isn't it? So when we're all done, we got to take 1 minus that. Because that's the opposite of 3 or more. Yeah. Oh, is that where it's at? It's under probability?
No, you forgot it. It's
Yeah, right here in the middle should have been the probability. What was the probability? 41 or something? Yeah, 41. 0.41. So 0.41 and then 2 or less. Because ours is 2. 2 or less is the opposite of 3 or more, isn't it? So we're doing the opposite, and then we got to take, when we're all done, take 1 minus the answer. So let's get the answer to this first off. Yeah, so it's under second vars. Second vars, yeah, binom CDF. 0.665. I don't know how many places they want. What do they want? 4. 6651. But then we have to take 1 minus that, huh? 6651, and then we got to take 1 minus the answer as it says there. So 1 minus the 0.6651 equals 0.3349. There's our answer. Yeah, the question was at least 3. So at least 3, the opposite is 2 or less, 0, 1, or 2. So I did the binom CDF with the opposite because that's just how they wrote the program. You can only do 2 and below, or numbers and below.
So mine is at least 2, so I would do 1.
Yeah, exactly. You always got to do the opposite of what you've been given. Michaela.
So in the test, all the questions, like, it'll always be 1 minus the answer. It's never the answer we give.
No. Look down here. See, yeah, there's other versions. That's just this one. If they say exactly, use binom PDF instead of CDF. If they say more than, then you do CDF with some other things. If they say as most. So I'm giving all different types. Yeah.
This is the one I failed miserably.
Exam 2? Yeah, this is the tricky part. So 0.3349. Oh, how we doing? We got 40 minutes. We got to get a little further than this. All right. Assume, number 10. Assume that adults have IQ scores normally distributed, mean, 97 standard, 17.7. Find the probability that a randomly selected adult has IQ score greater than 130.1. Hint, draw a graph. Probably the randomly selected adult from this group has IQ greater than 130.8 is, okay.
is this the thing where you either do like the positive 999 and like the negative?
I think so. Yes.
Okay.
I believe so. Yeah. All right. Yeah, it's been a while. Been a while on these. This is the hardest stuff. This exam 2 stuff. It's been the longest. It was hard material. Okay. So draw a graph. Now, when I say graph, what graph do I mean? I mean the U thing, right? The bell curve. Yeah. Yeah. It's not a U. It's a bell. Yeah. Bell curve. Yeah. So the bell curve graph. Here's the middle. Now, what goes in the middle?
97.
Mean 97. Standard deviation, who cares, whatever. Find the probability that the IQ is greater than 130.8. So where's 130.8? Way over here, somewhere real high, 130 or greater. So to the right of that. So it's just helpful to see that. I think it'll kind of keep you straight on what to put in your calculator. Does that make sense? There's a picture of what they're saying. The mean's 97, they want 130.8 or greater. If they said less, I would have shaded to the left, wouldn't I? That makes sense? So greater numbers are to the right, as you know. Lesser numbers to the left. So just shade whichever way they said. They said greater. Greater is to the right. Okay, so now what are we going to do with this thing? I think this is it. Notice they give a mean and a standard. Yeah, that's us, right? They're giving us a mean and a standard. So when they give you a mean and a standard, and they ask for a percent, is that what they're asking for?
Yeah.
Probability, which is a percent, huh? Yeah, they want a percent, which is the same thing as probability. Okay, so normal CDF, left, right, mean, standard. There it is. Normal CDF, left, right, mean, standard. So normal CDF, left, right, mean, standard deviation. So that's under second var again, right? We have done a lot of stuff with this calculator. Okay, so now when we say left, right, all that, what are we referring to?
The shaded region.
The chunk that's shaded, exactly, Eddie. Is everybody with Eddie on that? It's this stuff. We mean what's the left edge of that chunk and the right edge of that chunk. So what's his left edge?
130.
The 130.8, yeah. That's his left edge. What's his right edge? Yeah, forever to the right, just go 99, 4 nines if you want. You know, just as many as you want. Just make sure it's going to infinity, basically.
It's not
You know?
point, it's just 999.
It's what? Just a whole bunch of nines, yeah. Because basically you want like a zillion there. You just want a huge number. And then the mean, they gave us the mean, that's 97. And the standard they gave us, 17.7. Hit the buttons. That sounds like January weather in May. So, what are we getting? I got the answer 0.028. How many? 0.0281, I guess, 4 decimal places. 0.0281. That's the probability. Very low probability, right? 2%, just under 3%. So the trick is going to be identification, isn't it? That's going to be the real battle. I think you all know the buttons and all that stuff, but it's like reading that and figuring out that it's normal CDF. That's going to be the real battle. That's what you want to help yourself with over this weekend. Practice. When you read that question, will you be able to identify, oh, it's normal CDF because of what they're giving, the information they're giving you? That's hard to do. 25 questions, 18 weeks of math. Math science, I had to go crazy studying for math science finals because the identification is so hard to keep it all together. Anyway, is that good? Anything I can answer on that? No, survey found that women's heights are normally distributed mean, standard, men's heights, mean, standard, most of the live characters at the museum parks, blah, blah, blah. All right, what's their question? The percentage of men who meet the height requirement. What height requirement? Oh, this height requirement. Okay. So the percentage of men meeting the height requirement. What's the height requirement? Minimum of 56, max of 62. So notice they're giving for men, they're giving me a mean and a standard. That's for men's heights. Mean and a standard for men. What should I use? How do you know what formula to use here?
CDF, no, because it's deviation.
Exactly. Does everybody see that this is the battle, huh? Is identification. Do you see, because they're giving me means and standards, I'm going to do the same thing I did in the last problem. Right? I'm going to go back here. When they give you a mean and a standard and they ask you for a percent, that's what they're doing, aren't they? They're giving me means and standards and they want a percent. So you go, okay. So that's why you want to have this on your sheet, is this identification is probably the main thing. So don't just put this down. Put down how you identify it, because they're giving us a mean and a standard, and they're asking for a percent. All right, normal CDF, left, right, mean, standard. So, and it's helpful to draw the picture. You don't have to, but it might help. So if I was to draw the picture real quick, for men, what's the mean? Middle, 67.8, and they're asking between 56 and 62. Where's that? Where's 56 and 62? Left of the middle, right of the middle, around the middle?
Left, all left.
Both those are. It's this chunk between 56 and, let me move this over, and 62. Huh? And the middle is that 67.8. Yeah. Okay, so that's what they want. They want that percentage there. So normal CDF. So it's going to go left edge. What's the left edge? 56, right? Right edge. 62 mean. 67.8 standard. 3.8. There. 3.8. Hit the buttons on your calculator. I'm getting, what I get? I got 0.0625 6.15. Now I have to turn it into a percentage, right? See how they're asking for a percentage here? So that means you got to move it 2 places, right? Everybody see the difference? I don't want you to miss this on your practice final and end up wasting time. So yeah, because they want a percentage, you got to move it 2 places. So that's 6.25%. So 6.25% of men fit the height category to be Goofy and all the other characters at the live characters. Not many men fit that. Okay, since most men what do not meet. Most men do not, right? Only 6% of men do. Height. It is likely that most of the characters are women. All right, next. If the height requirements are changed to exclude only the tallest 50% of men and the shortest 5% of men, what are the new height requirements? Yeah, that's a tough question. So we good with this one? I'll move on to that part. You get a fresh screen. We good there? So that first part wasn't bad. This next part's a little more tricky. So let's go back with the same graph again. We're doing part B now. So here's the graph. The middle was 67.8. Okay, now what they're saying to me is they're saying you're going to change it. You want to exclude, like out, you're not included, exclude the tallest 50%. So that's the tallest 50%. That's the upper half, right? And the shortest 5%. So down here, this is the shortest 5%. See what they're saying? So they're saying we want to know the 2 height marks that would be, right? They want a minimum height and a maximum height. Well, this maximum is 67.8. But I don't know this minimum one. I got to find it. Am I going too fast? Do you see what's happening? So they're saying on this is a hard question. They're saying same graph, same middle, same average for men, 67.8. But now we're changing it. We want the tallest 50%, which is the upper half, out, and the smallest 5%, the shortest 5%, out. And they want me to find out what heights that means. Well, this one is, the middle is 67.8. That means men with heights between whatever that lower mark is, which I'm going to find in a second, and 67.8 are the ones that can be in the live characters. How we doing? It's good so far. Now, the whole battle is, how do I find that lower number?
Is that the inverse?
That's the inverse norm. Remember inverse norm? Let's go back to our notes. How do you recognize it? When they give a percent already. See how they're giving me, they're giving me the 5% already? Do you see that? So in the second question, I'm not trying to find a percent like I did on the last one. The last one I found the percent. Now they're giving me the 5%. Aren't they? So that's inverse norm. Remember how we learned that? So that's when they give the percent already. That's inverse norm. Area left, mean, standard. So I'm going to do inverse norm, area left, mean, standard. So, okay. Now, can you read it? That's kind of a bad spot. I'll put it up here. So, inverse norm. So what's the area left?
0.05.
Yeah, that's the 0.05, isn't it? That's the area to the left of that spot I'm looking for. I'm trying to find this height right here. What's the lowest height for men to be the live character? Area to the left is 0.05. Area to the left of that spot, the mean, 67.8. The standard, was it 3.8? Yeah, thanks. 3.8. All right, hit the buttons on the calculator. I'm getting 61 point, I don't know how many places they want, 1 decimal, 61.5. So the min there need to be, the lowest they can be is 61.5 inches tall. That's the minimum, up to 67.8 inches tall. So that was kind of tricky, wasn't it? Are you okay with that? There is one on the final, since I made the final today, I know. There is one in the final. I don't ask you a million questions like this. I just ask you the one. On one question, I just hone in. And I give you a percent, and I say, find the number. So not like a million questions, like this is overkill. I just ask you that one specific question. So you'll be fine as long as you have on your sheet that when they give you a percent already, that's when you do inverse norms. As opposed to when they ask you for percent, you do normal CDF. So have that on your sheet, and you'll be able to get it. And you'll know these kind because they're all about means and standard deviations, aren't they? Is that good? Anything else I can say on that one? All right, number 12. The overhead reach distance of adult females, normally distributed mean, standard, fun probability, individual. Okay, this looks like the same. It's got one small difference. Let's answer question A first off. So, again, I'm going to draw a normal curve. You don't have to, but it might be helpful. The middle mean is 205. And, okay, and so they're saying, find the probability individual is greater than 217.5. So I'll come over here to 217.5, right? Yeah. And greater means to the right. So I want to find the percent or the probability, same thing. So if they're asking for a percent or a probability, you know the deal. Let me erase all my scribbles here. When they ask for a percent, it's normal CDF. So when they ask for a percent, it's normal CDF. Left, right, mean, standard. So let's do that. So question number 1 here. Normal CDF. So left. What's the left?
217.
That's the 270. It's the left of the shaded chunk. Yeah, so it's the 217.5. The right edge? 999. Now, I didn't give you one where it went off to the left. What if it went to the left? What if they asked me for some kind of shading here? What would the left edge be? Minus 999, right? And this might be whatever, 17.3 or whatever it is. Yeah, just want to make sure you can do that too. Okay. So, right, and then what? Just mean and standard. So the mean is 205. Standards, what is it, 7.8? Hit the buttons on your calculator. No problem. Get the answer. So I'll do it too. I'm getting 0.05. How many places? About 4 decimals. You know, you might want to make this 4 nines, just to be sure. You need to really get infinity in there, so put 10 nines if you want. You don't want to cut it too short. It might give you an error. So just put a bunch of nines. When you do the nines thing, I probably set it to, I didn't give you enough nines. Just to make sure, you know, put in like 4 or 5 or 6 nines. Anyway, I'm getting 0.0545, 4 decimal places. And that looks like a small percentage. Doesn't that look like, you know, a tiny percent? Looks good. Next question. Now here's really what I want you to say. Question B. Find the probability that the mean for 15 randomly selected distances is greater than 203.5. How do we do that?
We do the 7.8 divided by square root of 15.
Beautiful. Exactly. Remember when they give you a group? That's when I did that. Remember that whole crazy thing I had us do where we all got online and we tried to do the die rolling thing? Probably meant nothing to you, huh? I'll have to improve that activity to be meaningful. But basically, I was trying to give you the idea that when you take groups instead of individuals, things tend towards the middle. So anyway, that's what we're talking about here. You basically do, everything's the same there. All you got to do is exactly what Val was saying, is you just got to come in here and take this last number and divide by the square root of 15. That's it. Just make that standard deviation. So when you have a group, take the standard deviation, divide by the square root of n. Everything else is the same. So on question B, we see question A was an individual, right? See how A said an individual, one person, and B said 15 randomly, a group of 15. So when you have a group, then just divide that by root 15. That's in the notes somewhere. Yeah, there it is. Notice when n is not 1, standard deviation over the square root. It's off the screen, but
Is that how you punch it in?
How do you punch it in again?
so
Second next
yeah, it'll literally be
2.8 divided by-
exactly like I have it there. 7.8 divided by square root of 15.
7.8.
That's what I'm doing.
Yeah, how do you punch it?
It's 7.8. You put divided.
With the E thing. What I got is 2.716 blah 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 E minus 10. Remember what that means? Decimal back 10, so it's basically 0. So you're supposed to take this decimal and go back 10. So one jump and you're to the edge. The other 9 zeros. Does that make sense? So it's just 0 on that. You guys getting that? Change number here. Okay, let me do it again.
3.5.
All right, let's do it again. So, yeah, they said 15 and 203.5. Okay, so what that means, again, here's the normal thing. The middle is whatever it was, 205. And now they're saying 203. Yeah, see, where's 203? If 205 is the middle, where's 203? Somewhere to the left. They're saying 203.5. Do that a little better. 203.5, and they're saying what? Greater, so that means to the right. So look, that's more than half, huh? We know our answer's got to come out more than 0.5, doesn't it? Now that I've got the right number on there. Right? So now we do normal, CDF, left edge, right edge, mean, and standard deviation divided by the square root of 15. Because there's 15 in there, so... Normal CDF, left edge, 203.5. Right edge is just not, put a bunch of 9s, like 5 9s or whatever. More is always better. Mean is 205. Standard deviation is 7.8. Divided by the square root of 15. And we're expecting an answer more than 0.5. Okay, yeah, I got 0.7718. Whew. All right, so we good on that one? What did they say there? The normal distribution can be used. What was the correct answer below here? Why can the normal distribution be used? Oh, it's because I don't know.
Grab it.
Oh, standard deviation. No, normally distributed. Yeah, the original can be used because. The original is normally distributed. There we go. The original is normally distributed. Yeah, don't worry about that. I'm not going to ask you about that. All right. It's on the practice exam, though. So, number 13. All right. So, we're done with exam 2. On to exam 3. Justin.
For number 12, like on the answer sheet for your practice exam?
Did I not put that answer?
Never mind.
Let's see. Survey, a bunch of adults. Was found that 85.4% of them used at least one prescription medication. How many of the 3495 used at least one? Oh, so let's start with that. So how do we figure that out? So it's 85.4% of 3495 adults.
You just divide that?
So So what does of always mean in math?
Multiply.
Means multiply. Yeah. That good? So yeah, just change this to a decimal and just times it by 3495. They're saying 85.4% of the 3,495 adults. They're saying how many is that? You just multiply. Of always means multiply. So move the decimal back 2 places. Of is multiply. And get some number on your calculator.
To the nearest integer?
It was round to nearest integer. Yeah, I'm getting
95?
298. Yeah, 5. It'll round to 5 exactly. 2985. So 2,985 of them use at least one prescription medication. Question B, construct a 90% confidence interval. So here we are back to the stuff we're used to. Confidence intervals, hypothesis tests, that all started at exam 3. So exam 3 and 4, it's been that the rest of the way, hasn't it? So, all right, so we want to do a 90% confidence interval on this one. So what are we going to do?
We're not minusing the 1 minus the on this part, right? On this
No, nothing like that. None of that monkey business, yeah.
That's Untitled Chapter 4.
Yeah, that's just earlier stuff, exam 2 stuff. Yeah, we're in exam 3 now. So, how, which kind of confidence interval are we going to do on our test? Notice it's a P, huh? So we're going to do, yeah. It's, what is it? It's
What prop, Z? No.
1 prop Z, one prop Z interval. Yeah. So we need the 1 prop Z interval. Getting the hang of all those names on everything? It's proportion, right? It's a P. It's not a mean. Right? Everything we did in confidence intervals hypothesis were either proportions or means, weren't they? So this is a percentage, not an average. It's a percentage, not a mean. Proportion, not a mean. So 1 prop Z interval. Just go there. And it asks you for the... So the X, when you do 1 prop Z interval, asks you for the X. What's the X?
Do we do the 2985 or
Yeah.
do we do the 2984.73?
No, yeah, just put in the 2985. They want a whole number. 2985. You're saying 2985 out of, and what's in?
3495.
Yeah, the total number. Because what you're basically saying is 2985 adults out of 3495 did the whatever this thing is, prescription medication. And what's the confidence level? 90? Calculate. So I'm getting, they want one place. So 0.8. Oh, they want a percentage. Notice they want a percentage. So we got to change this. So I'm getting, move your decimal 2 places. 84.4%
Yeah.
to 86.4. Is that good? All right, coming out. So this is more familiar territory, right?
Yeah.
So it's the first 2, especially exam 2 material, that's the toughest to remember and weirdest. And then what does this mean? What do the results tell us about the proportion of college students who use at least one prescription medication? What does it tell us? Did you notice what they're doing? I'm not going to ask you this question. They changed it from college students,
To adults,
from general adults to college students.
have nothing in common.
Yeah. So it tells us nothing. Tells us nothing. All right. So we good on that confidence interval?
Yeah.
Let's do 1 or 2 more of these. We'll be done here. This is better stuff. So 1 prop Z interval. Right. Yeah. A lot of words. Clinical test. Some drug. 16 subjects. Blah 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 blah. They want a 90% confidence interval. So that's the same thing. But this one, how's this one different than the last one? Mean, yeah. 90% confidence interval on the mean wake time. So we go to our calculator. What are we going to do? Which test are we going to do? So it's not a test. Tests are for hypothesis tests, right? It's going to be,
Sample interval.
isn't it? Oh, yeah. You're right. Oh, no, those are two samples, aren't they?
Is it Z interval?
It's just T. Yeah, we never use Z when we have a choice. Yeah, let me, I noticed that too. Here, let me say a word about that. The only time we use Z is for the proportion. Probably the easiest way to remember it, if you look for proportions on your list there, for proportion, you don't have a T option. All you've got is Z. So what I learned to do in my mind, maybe this will help you, is basically anytime I have a choice, like if there's a T and a Z, always choose T. So let me write that down.
Never use Z.
We only use Z when there's no other choice, which was under the proportion. So when there's a choice, when you're looking at your list going, oh, I could do there's like for this one, there's like a T interval or a Z interval. When there's a choice, you always choose T. When there's no choice, and that would be for proportions, when there's no choice and all you've got is Z proportion interval or whatever it says, well then obviously you do that. There's no choice. Basically the only time we're going to be doing Z is when there's no choice. So anytime you have options, so if you're looking at your list, like right now, if you look down at that list, you'll see T interval and Z interval. It's not two sample, right? We don't have two samples here.
Wait, is it though? Because there's two means.
There's not two means.
Oh no.
Yeah, there's just one mean. I mean, there's a lot of words there, I know. But there's just one mean there. See, it even says the mean. So yeah, there's just one mean, so it's not a two sample. It's just one mean, and so we're going to do T interval. Whenever you have a choice with T and Z, always do T. So do T interval, and you'll choose stats because we don't have data. You know all about that. And they're going to ask for the X bar. I don't know what X bar is. What is the X bar? Me, 79.2? And a standard, 21.1. 21.1.
90% confidence level.
Is that what it is? Yeah. Oh, what's in?
It's 16.
Oh, 16, yeah. In is 16 subjects. Confidence level was 90. Calculate. I'm getting, and they want rounded to one place. It's actually 70.0 to 88.4. That's what I got. Let me make sure. And all right, let's answer the last question. We will be done. What's the last couple questions on this one? What does the result suggest about the mean wake time of 101.1 before the treatment? Yeah, that was the mean before treatment. So I know what you mean. Like Michaela, when you were saying there's two means, you're right in the sense that there was another mean that before treatment didn't get the drug. Yeah. So anyway, what does it mean? 101.1, is that in the interval? No, that's not between 70 and 88. So what does that mean? It looks like the drug lowered the wake time. It's good. The drug's doing something, right? The average wake time before taking the drug, people were awake 101 minutes. After the drug, it was lower. So that's better. That's good. That seems like the drug's working. It lowered their wake time during the night. So the confidence interval does not include the mean wake time of 101. So the mean before and after the treatment are different, right? It looks like there's a different average. The drug's doing something. This results suggest that the drug treatment has a significant effect because it changed the wake time.